Namaskaram everyone. Dear students, good morning and welcome to another interesting session of mathematics webinar. In continuation of the previous session, which started with introduction to trigonometry, Madam V.USHA is going to teach you today periodicity of trigonometric functions and the compound angles of trigonometry. Without wasting much of your time, I request Usha Madam to continue with the session. Over to you, ma'am.
Thank you, Madam. Good morning, everyone. Dear children, in the previous session, we have discussed the basic things in trigonometry, what you have learned in your previous classes, and also an extension of the concepts. And the very important thing what we have learned is ASTC property, isn't it? ASTC, all silver teacups, right? All in the first quadrant, sine and reciprocal of sine in the second quadrant, tan and its reciprocal, that is cot, in the third quadrant, and in the fourth quadrant, cos and its reciprocal secant are positive. That is the very, very important thing you need to keep in mind always whenever you are dealing with any trigonometric problems. And not only that, we have seen trigonometric ratios, how they are varying in different quadrants. Of course, their sign will be decided by ASTC property. 90 plus theta, 90 minus theta, we were discussing the odd multiple of 90 and even multiple of 90. Based on that, we were writing the values of 90 plus theta, 180 plus theta, and minus, and so on. Not only that, we had discussed trigonometric identities. Trigonometric identities like secant square theta minus tan square theta equal to 1. We try to make use of a plus b into a minus b formula, and we try to we have tried to see how we are applying that concept in solving the problems. Okay, today we are going to see few more problems which are dealing with the trigonometric concepts what we have seen yesterday and an extension of that. Okay, now the today's concepts what we are taking are periodic function and period of different trigonometric functions, then graphs of trigonometric functions, domain and range of the trigonometric functions. Now, by this time, when I say domain and range, it should flash in your mind the concepts of domain and range in the functions topic what we have discussed, isn't it? Then we'll see maximum and minimum values of the trigonometric expression which is given to us, and then trigonometric ratios of compound angles. And also, we will try to solve the problems on all these concepts. Right, children? So, we'll quickly move into the topic periodic function and period. Now, before we get into this, what is periodic? Isn't it? The English meaning of periodic is what? Hope you know. We'll keep on using this very frequently when we talk, isn't it? So periodic, it means appearing, something appearing at or occurring at regular intervals. The same concept we are applying for trigonometric functions also. Okay, so periodic function and period. If you have any real function, f maps a to r, is said to be a periodic function if there exists a positive real number p such that f of x plus p is equal to f of x for all x belongs to a. Now here, if you can observe, this f maps A to R is a real function which is using the real values. Okay, children. Now you have a positive value P. Now what you are going to do with this P? In the given function, instead of x, if you are substituting x plus P, still if you are getting the answer as f of x, then that P and we are choosing P in such a way that it is a least positive value, then we call that value P as period of that particular function. Now, what exactly is this? Why we are trying to take only the least positive real number? We will look into this by taking some trigonometric ratios with the help of graph, and then we will see what is the exact meaning of this least positive real number, right? So quickly we'll go with graph of the trigonometric functions. First, we will start with the sine function, children. Now, every one of you know, and you're very familiar with the drawing of graphs, right? So before you draw any graph, you will try to take a table, what to be taken on x-axis and y-axis, isn't it? So we will try to take a table. Here, when we are dealing with the trigonometric ratios, we will talk about angles on x-axis, okay? So the values which we are choosing here are x with 0, pi by 2, pi, 3 pi by 2 and 2 pi, and the same angles with the negative sign. Now, hope by this time you are very familiar with what is pi by 2. Pi by 2 is 90, 3 pi by 2, which will be 270, pi will be of course 180 degrees, 2 pi will be 360 degrees. And we are also taking the negative angles, that is minus 90, minus 180, minus 270 and so on. Now already we have seen the standard values of these angles with sine. So we'll quickly fill the gaps what we have with sine x. Sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1, and sine 360 is 0. All these values we have seen, children, right? And sine of minus 90 is minus sine 90, isn't it? So sine 90 is 1, so your value will be minus 1. Sine of minus pi is minus sine pi, but sine pi is 0. So minus 0 is again a 0 value, right? The value will be 0. Then sine of minus 3 pi by 2, that is minus 270 degrees. So sine of minus 270 is minus sine 270. Then minus of minus, that gives you plus 1 over here. Then we have sine of minus 360 is minus sine 360. Sine 360 is 0. So minus 0 is 0 again, right? So we will take all these values, the angles on x-axis, will take the points 0, pi by 2, pi, 3 pi by 2 and 2 pi on the positive side. And on the negative side, we are taking minus pi by 2, minus pi, minus 3 pi by 2 and minus 2 pi. Now, if you can observe your graph, sine graph, and I mean the table, then the maximum value what you are getting is 1 and the minimum value is minus 1. You have studied regarding this in your previous class. The value of any sine function lies between minus 1 and 1, isn't it? So the maximum value is 1. I'm just demarcating it with a line, and at minus 1, that will be the minimum value. Now children, sine 0 will be here at 0. Sine 90 is 1, so it touches the line over here. And sine 180 is 0 again, so the curve comes down. And if you can take the values between 0 and pi by 2, they will be lying here in this gap, isn't it? But whatever value you take, suppose if you take sine 30, it is half, 0.5, that is less than 1 only. That means the sine function, whatever value it takes, it will not exceed 1 and minus 1. That you need to remember. Now, if you take the graph from 0 to pi, it is taking a curve in this form. Of course, it is touching the line which is drawn at 1 exactly at pi by 2. And still further from pi to 2 pi, if you take, the curve goes in the reverse direction. Now it is forming a crest and a trough, like what you see in your physics, your transverse wave form, isn't it? A crest and a trough. Now to take this form, it is traveling from 0 degrees to 360 degrees. Now on the negative side also we will try to take the same thing, children. So from 0 to minus pi, it is taking the reverse direction in the line in the direction just below your x-axis, isn't it? So this is the curve what you're getting from 0 to minus pi, and minus pi to 2 pi you're getting a graph like this, again a crest and a trough. Now observe this, from here to here it is pi radians 180 degrees, and from minus pi to 0 it is another 180 degrees. So it is totally 360 degrees from here to here. At the same time, just observe from 0 to 360 again. The distance from this point to this point is 360 degrees. So one crest and one trough. To get this pattern, you are traveling a distance of 2 pi radians. You are taking 2 pi radians, isn't it? So the pattern of the graph is repeating exactly after 2 pi radians. So we can say the sine graph is periodic. It is repeating, or it is taking the same pattern exactly after 2 pi radians. So we can conclude saying that the period of sine function is 2 pi. Right? See, after 2 pi, say from here to here it is 4 pi. Can you say 4 pi as your period? No. Just now in the previous slide, we were talking like P will take the least value, isn't it? So this is the meaning of least value. At 2 pi, you are getting a pattern like this. At 4 pi again, you will get the same pattern, and so on. So period of any function will be taken by considering the least possible value of P at which the function will take the same pattern. Now we'll try to take another function, that is cos function. Here again we will consider the table, children. The same standard values we will try to take. Then cos 0 is 1. Cos 90 is what? Cos 90 will be 0. Cos 180 is minus 1. Cos 270 is 0. Cos 2 pi, that is 360 degrees, it is 1. Now cos is an even function, that we have seen in the previous class. So even function, so when you take negative angle also you will get a positive value, isn't it? So you have cos of minus pi by 2 is cos pi by 2. Cos pi by 2 is 0. Right? Cos of minus pi is minus cos pi. Sorry, cos of minus pi is cos pi. Cos pi is minus 1. Cos of minus 3 pi by 2, it is cos 3 pi by 2 only. So the value is 0. Now likewise, cos of minus 2 pi, it will be 1. Now we'll try to mark the same values on the graph, children. So you're taking x and y axis. You're marking all the angles on your x-axis. Okay, 0, 90, 180, 270, 360, minus 90, minus 180, minus 270, and minus 360. Now, here again, the cos function will take the maximum value as 1 and minimum value as minus 1. So cos values will be taking between minus 1 and 1 up to 1 and up to minus 1 only. It will not go beyond that. So here again we will demarcate that with a line. Okay. Now cos 0 is 0. Cos 0 is 0. And cos 90, sorry, cos 0 is 1. So cos 0, it will be here exactly at this point. Cos 90 will be 1. Cos 90 is 0. So the point will be here. Then cos 180. Cos 180 is minus 1. So it goes in the reverse way. Cos of minus 90 is 0. So here is 0. 0, 1 and then 0. So here you are getting a crest. But did you observe the difference between sine and cos? Sine is taking 0, sine 0 is 0, but cos 0 is 1. So here it starts. Then next, from pi by 2 to 3 pi by 2, it is forming a trough. It is taking the negative direction, right? And then from 3 pi by 2 to 5 pi by 2, if you take, again it forms another crest. Then next, in the reverse direction, if you take, I mean in the negative direction, minus pi by 2 to minus 3 pi by 2, it is taking in the negative direction, right? And so on. It continues. It continues. So it means what? Here again, to get a pattern, see, the pattern is repeating. Did you observe this? The pattern is repeating. Now from here to here, see, minus 3 pi by 2 to minus pi, it is 90. From here to here, again 90, so 180. From here to here, it is 90 again, so 270. Then from 0 to pi by 2, another 90, so 360. So 360 degrees when you take, see, the curve is one crest and one trough. Then again one crest and one trough for another 360 degrees. So the cos function is also periodic, and its period is 2 pi. That means after every 360 degrees, it is taking the same pattern. The pattern is repeating. So from this, we can conclude saying that sine and cos are periodic functions with a period 2 pi. What is this period telling you? After every 2 pi radians, the pattern of the graph will be repeating. Got it, children? Then quickly we will move to the tan function. Now tan function is little special, I should say, because we have some undefined values also for tan. But sine and cos, they are defined very much. So it was very easy for you to mark the graph, and you are very familiar with that type of graphs, right? Now for tan x, we will see, children, tan 0 is 0, tan 90 is an infinite value, or it is not defined. Infinity is not defined, right? So tan pi is 0, tan 3 pi by 2, that is 270 degrees. It is again an undefined value, right? And tan 2 pi is 0. And likewise, if you take tan minus pi by 2 is an undefined value. And of course, tan is an odd function, sine by cos, right? So tan of minus pi is 0. Tan of minus 3 pi by 2 is not defined. And tan of minus 2 pi, that is minus 360 degrees, is 0. Now, how to take the graph when you have an undefined value? Now we are taking the coordinate axis. We are marking the points. 0, 90, 180, 270, 360, minus 90, minus 180, minus 270, and minus 360, right? So now, observe this. You are taking 0, tan 0 is 0. That means the graph will touch here, no doubt. Then tan 90 is not defined. Now, if you have an undefined value, observe this. From 0 to 90, if you are taking the values, they are positive values. So tan 30, if you take tan 30 is 1 by root 3. Tan 45 is 1. Tan 60 is root 3. They are 1 and above 1, isn't it? Like that, if you mark, you will get a curve. At 90, you are getting an undefined value. that is an infinite value. Infinity is not known to us. So we are just demarcating with a line so that the graph is not touching this line. Now, if it is touching this line, what does it mean? It is taking that particular value. But no value we are marking at 90 because we don't know what exactly is infinity. Now, from 0 to minus pi, when you go, it is again undefined, but in the negative direction. So the graph is coming down here. At the same time, here again, at minus 90 also, we will demarcate with a line so that we will understand that the line, see, if you are not drawing this line also, it hardly matters. Then why is that we are just taking this line? Just to have a clarity that at that particular value, at tan 90, right, the graph is just extending like that, but it is not taking any particular value. The reason is the value of the function at 90 degrees is not defined. Okay, so at exactly wherever you are getting an undefined value, I am trying to show that with a line so that you will understand at that particular line, the green line which you are able to see, you can understand that the function is taking an undefined value. Just observe this. The function is taking an undefined value exactly at multiples of 90. Did you observe this? Multiples of 90. What multiples of 90? Odd multiples of 90. See, 1 into 90, 3 into 90, minus 1 into 90 and minus 3 into 90. That means exactly at odd multiples of 90 where the multiples are integers, they may be positive or negative. At that particular values, the tan function is taking an undefined value, right? Then we'll see the cot function. The same standard values we will consider, children. Cot 0 is an undefined value, right? Cot pi by 2 will be 0. Cot 180 will be an undefined value. Then cot 270 is 0. Cot 360 is not defined. Likewise, in the negative direction also, we will take the values. Then let us see how the graph is. We are taking the points 0, 90, 180, 270 and 360. Just observe. We are taking in the negative direction also. Now, cot 0 is not defined, right? But cot 90 is 0. At this point, the curve is touching x-axis. Now let us have this pattern. At 0 degrees, cot is undefined. So just observe, the curve is not touching this line. Exactly at 180 degrees again, the curve is not touching. Why? Because the value at this pi is not defined. Got it? Now the same pattern we'll try to take further. Now I want you to observe an important point. Now we have seen the graph, but we need to talk something about the periodicity also, isn't it? So how is this pattern? From, look at this children, 0 to 90. 0 to 90 in the negative direction. So when you take 180 degrees angle from here to here, you are getting a pattern this way, a curve like this. Now the same pattern is repeated exactly after 180 degrees. Observe this. After every 180 degrees, you are getting a pattern in this form. That means the period of tan x is 180 degrees, right? After every 180 degrees, the tan function is trying to take, the tan function is taking the same values what you are getting for the previous 180 degrees. Okay, so the period of this function tan is 180. Likewise, just observe this, from 0 to 180, you're getting a pattern. Then 180 to 360. That means again 180 degrees. So you're getting the same pattern. That means here again, the period of cot function is also pi. Now, four functions we have seen children. Sine and cos functions period is 2 pi. But when you talk of tan and cot functions, the period is pi. Okay. We will take the next trigonometric ratio or the function f of x is equal to secant x. We are taking the standard values as we have seen for the previous graphs. Okay. Now, secant 0 is 1. Secant 90 is not defined. 1 by cos, 1 by cos 90. Cos 90 is 0. So 1 by 0 is not defined. Now likewise, secant 180 degrees is minus 1. 270 is not defined. Secant 360 will be pi. Is 1. Secant of minus pi by 2 is not defined. Secant of minus 180 degrees is minus 1. Secant of minus 3 pi by 2 is not defined, and secant of minus 360 degrees is minus 1. Now, did you observe how the values are, children? Except for sine and cos, the remaining functions are taking the values till infinity in the positive and negative directions. But tan and cot, when you see, they are taking the values from minus infinity to infinity. But here, when you talk of secant, there is some restriction. What it is, we will try to see with the help of a graph. We are taking the coordinate axis. We are just marking the points 0, 90, 180, and so on in the positive and negative directions. Now, secant 0 is 1. So exactly at 1, you will have a point. Now, secant 90 is not defined. That means at 90 degrees, it will not take any values. Just to show that we are taking this green line. At secant of minus 90 is also not defined. So we are just, we will again take a line over there also. Now, from 90 to 270 degrees, 90 to 270 degrees, it is taking a negative value minus 1 at pi, and at of course at 90 it is taking a negative value, and if you continue from 90 onwards, it takes a negative value. So you are able to see that in the fourth quadrant. Now it is a parabola facing downward. Now you can say this is a function which is not continuous. When you have seen sine and cos, they were continuous functions. When you have taken tan when you have taken exactly at 90 degrees, the curve is breaking. Here at 90, again the curve is breaking. It is a discontinuous function. Okay, children. Now, this is the pattern what you're getting. Now, observe this from here to here. How many degrees you have taken? 180, isn't it? This is minus pi to minus pi by 2 is 90, and minus pi to minus 3 pi by 2 is 90. So this is 180 degrees. Another 180 degrees here. So 360 after traveling from here to here, again you are able to see the same pattern. That means secant function, the function secant is also periodic. The period of this function is 2 pi. Okay, now we will quickly look into cosecant. Cosecant, again we are taking the standard values. Cosecant 0 is not defined. Cosecant 90 is 1. Cosecant pi not defined. So likewise, we are taking the values, the standard values in the table. Then just observe the graph. We are marking the points over here. Then 0 to pi. Of course, in between you have 90 degrees. At 90 degrees, cosecant is taking the value as 1. Exactly here. From 0 to pi, when you say at 0, you are getting a not defined, that is an infinite value. Therefore, it is not touching any, it is not taking any value at this point. And at the same time, at 180 degrees also, right? So just observe the pattern, children. Here again, after every 2 pi radians, the same pattern is repeated. Therefore, period of this function is also 2 pi. Right? Now, we will take some conclusions based on these functions and the graph. What did you conclude, children? What all the trigonometric ratios we have seen till now, they are periodic. So the first point we will say is all the trigonometric functions are periodic. Of course, the period of the functions is differing, but they are periodic, right? Okay. Now the next point is period of the functions what we have discussed. Sine and cos, the period is 2 pi. Secant and cosecant is also 2 pi. But for tan, what is the period? The period is pi. Then the maximum and minimum values of the sine and cos functions, what we have observed, it is 1 and minus 1, isn't it? The maximum and minimum values are 1 and minus 1. Then secant and cosecant values, secant and cosecant does not lie between minus 1 and 1. Minus 1 and 1, between that the values are not lying. And at the same time, when you take period of all these 6 trigonometric ratios with the modulus, when you take modulus, all the positive values, whatever you are getting, they will be of course positive. But when you are getting a negative value, for example, when you take something like secant of minus pi, secant of minus pi is minus 1. Right? So secant of minus pi, when you're taking in the modulus, it also becomes a positive value. That means you will not get a graph on the negative side. Therefore, period of all the trigonometric functions when you're taking modulus will be pi. You can try out drawing the graph of these functions with modulus. When you take modulus, children, the negative infinity also becomes a positive infinity, negative 1 becomes a positive 1. So all the values will be above the x-axis in the graph. You will not get anything below the x-axis. Therefore, then after drawing that, you can very well observe what is the period of the functions. Okay. Now, quickly, we will try to see what all we have discussed in the form of a table, the domain and range of the 6 trigonometric functions. Now, the functions, domain and range, all these things we have seen in our topic functions. When I was discussing the domain and range, we have kept certain things in our mind when we were finding out domain of the given function. Now, when you take certain value in the domain, and if you're substituting in the function, if you are able to get a functional value, then you can take that particular value as a value in the domain. But for certain values, when you substitute in the function, if you're not getting a functional value, a defined value, then you cannot consider that in your domain. That is what we have seen in functions topic, isn't it? So we will try to see what exactly we have observed in the graph previously, just now. Right. These are the 6 trigonometric functions what we have, children. Sine function, domain is the real numbers, all the real numbers, whatever you have, if you substitute, whatever theta you take, the value is lying between minus 1 and 1 only. It takes maximum the value as 1, and the minimum value will be -1. Therefore, it is closed interval -1, comma 1, right? Then cos theta also, all the real numbers you can take in the domain, and in the range, it will be only the same, that is the closed interval -1 and 1. Then tan theta, what did you observe in the tan graph? Exactly at 90 degrees in the tan function, the function is not defined. That means from the real number set, you need to remove all those values at which the function is taking infinity. Then you can define your domain of the function, right? So we have observed that tan is taking a value, a defined value, only when you are removing these things. What are these? See, 2n plus 1. What is this 2n plus 1? It is an odd number. Did you observe this? 2n represents an even number, and 2n plus 1 will be an odd number, right? So any odd multiple of 90, whether it is negative angle or the positive, you are getting an undefined value, right? So if you remove all those undefined values from the real number set, then you can define the range of this function as R. So domain of the tan function will be R minus 2n plus 1 pi by 2, where n belongs to integers. It can be a positive integer or a negative integer. Then the range will be R. Then cot value, what did you observe? Cot is taking an undefined value exactly at multiples of 180 degrees, multiples of pi. Therefore, we will try to remove multiples of pi from R. So you have R minus n pi, where n belongs to Z. So at this particular, when you take this type of values in the domain, then the range will be all the real numbers. Then secant theta. Secant theta also you have observed exactly at odd multiples of 90, the domain, the function is taking an undefined value. So we will try to remove all those odd multiples of 90. Then the range is defined as minus infinity to minus 1, till 1 it is taking, and from minus 1 to 1 it is not taking any value. That is what is that thing I wanted you to observe in the graph, and from 1 to infinity in the positive direction. Now likewise, cosecant theta is not defined at multiples of 180 degrees. So we will try to take away all those multiples of 180 from the real number set, right? Then at this domain, the range of cosecant function will be minus infinity to minus 1 union 1 comma infinity. That means from minus 1 to 1, the function is not taking any value. This can be considered as a discontinuous graph or discontinuous function. Now children, if f of x is a periodic function, we will try to see the important points. If f of x is a periodic function, like you can have a sine function or a cos function, any periodic function. Now, if we define the period of that function is p, then when you're calculating f of ax plus b, it is also periodic, and period of this function can be calculated by taking p by mod a. That means, did you observe this? You are taking the coefficient of a only, the coefficient of x only. F of x is periodic. Then f of ax plus b is also periodic. But we are not considering this plus b part. We are more interested in a into x only. So period of this type of function will be taken as p by mod a. Now, likewise, another conclusion what we will see is, if the period of f of x and g of x, if you're taking them as m and n, two different functions, where m and n are positive integers, then in that case, we are imposing one more condition. F of x plus alpha is not equal to g of x. At the same time, g of x plus alpha is not equal to f of x, then for any alpha belongs to R, then the period of f of x plus or minus g of x or f of x by g of x is k. And how is that k calculated? By taking LCM of m and n. In simpler words, I would like to put this problem in a simpler way. You have two different functions, children, f of x and g of x. But simply see, if he is asking you what is period of sine x, you will say it is 2 pi. If it is sine of 2x, then you will say, like by making use of this point, you will say 2 pi by 2. Okay, but if you have sine x plus cos x, then in that case, how to find? Sin x period is 2 pi, cos x period is 2 pi, but you have a plus sign in between both the functions. So in that case, you will take LCM of both the periods of both the functions. F of x will be sin x, for example, g of x will be cos x or tan x, any function. Then you will separately calculate the period of the two different functions. Then you will take the LCM of that. Then you will define period of the total given function. You will apply the same thing when you have one function by the other, f of x by g of x also. Okay, so quickly we will look into some problems based on this periodicity and period of different trigonometric functions. Now find the period of sine 5x. We have seen period of sine x is 2 pi. So according to the previous formula what we have seen, if for 5x it should be 2 pi by 5. This is a simple one, isn't it? So this type of questions you will be getting for a very short type questions for 2 marks. Okay. Now you have, we'll see one more problem. Tan of x plus 4x plus 9x plus so on till n square x. N square x. Okay. So now here, if you can observe this, all the terms inside the bracket have x. So I'm taking x common. Then we have 1 plus 4 plus 9 plus so on n square. Now observe these terms. Observe the values here. 1 can be taken as 1 square. 4 can be taken as 2 square and so on. Now they are nothing but, of course, you have seen this in your progressions topic in your 9th class, and also when you were solving problems in mathematical induction, you have found out the nth term of this type of problems, right? So this is looking like sigma n square form. Sigma n square is nothing but n into n plus 1 into 2n plus 1 divided by 6. So instead of this whole bracket, we can always write it as tan of n into n plus 1 into 2n plus 1 divided by 6 into x. Now observe children, period of tan x is what? It is pi. Then period of tan of n into n plus 1 into 2n plus 1 divided by 6 into x will be pi by n into n plus 1 into 2n plus 1 divided by 6. Of course, this 6, the denominator's denominator, this 6 will be moved to the numerator, right? So you will have it as 6 pi by n into n plus 1 into 2n plus 1. Now we'll see another problem. If you have a problem of this type, cos of 4x plus 9 by 5. This is what we were seeing in the note part of the conclusions. Okay, so I can take this 5 for both the terms separately in the denominator. So we are writing for our convenience as cos of 4x by 5 plus 9 by 5. But we know period of cos x is 2 pi. Therefore, period of cos of 4x by 5 plus 9 by 5 is 2 pi by mod of 4 by 5. So this can be taken as 5 pi by 2. 5 goes to the numerator and of course 4 and 2 they get cancelled. Now here when you are given with a function, directly you are calculating the period of the function. But when period is given, then how to go for the calculation of the function, right? Now we'll look into a problem of that type. Find a cosine function whose period is 7. He's saying it is a cosine function and he has given the period is 7. Okay, so we don't know what is the function. So we will consider the function to be cos some kx. Then we know period of cos x is 2 pi, isn't it? So period of cos kx will be what? It will be 2 pi by k. But what is that you are given with? He has given that it is a cosine function and the period is 7. Therefore, you can say 2 pi by k is equal to 7. This is period, 7 is also period. So we will equate both of them. Therefore, you will get k is equal to 2 pi by 7. Therefore, we can conclude saying that the required cosine function will be cos of 2 pi by 7x. Right, children? Then we'll quickly move to the next concept. If A, B, C are the real values such that A square plus B square is not equal to 0, then the maximum and minimum values of A sin x plus B cos x plus C will be given by the formula that is C plus root of A square plus B square and C minus root of A square plus B square over all real numbers. Now children, you are given with an expression which involves the trigonometric functions. Now A sin x plus B cos x plus C, or you can take A cos x plus B sin x plus C also. It hardly makes any difference when you take the formula for maximum and minimum values. If you're given with such type of expression and if you are asked to calculate maximum and minimum values, it is simple. You will just take these two values and go for the substitution. Now find the minimum and maximum values of 3 cos x plus 4 sin x. Now it is of the form A sin x plus B cos x plus C. So we'll try to compare this with the expression, the general expression what we have seen. So we'll say here A value is nothing but 4. B, isn't it? B is nothing but coefficient of cos x. So coefficient of cos x is 3 and you don't have any constant in this. Therefore, you will take it as 0. C is equal to 0. Therefore, the minimum value is C minus root of A square plus B square. So instead of A, B, C, you will just substitute the values which we have seen in the given problem. So 0 minus root of 4 square plus 3 square, which is nothing but, see, 4 square 16 plus 9 under root will be minus 5. 5 with a minus sign outside. Of course, under the root, you cannot have any negative value. That you have learned when we were discussing the functions topic. Now, the maximum value, C plus root of A square plus B square. Now, we'll just substitute the values of A, B, C, children. Then here again, this is 16 plus 9 under root, which is 5 with a positive side. Therefore, the maximum and minimum values which you are getting is 5 and minus 5. Now, we'll look into another problem. See children, this maximum and minimum values of any function which is given to you, you can calculate by taking this formula, and after learning the concept called derivatives in your second paper, you can also apply derivatives to this particular problem, and you can find out the maximum and minimum values even from that. Okay, after you complete that, you can try out in that way also. Find the range of 13 cos x plus 3 root 3 sin x minus 4. That is your problem. Then you are given that 13 cos x plus 3 root 3 sin x minus 4. You will try to compare this with the general expression. When you compare, you will get A is equal to 3 root 3, B is equal to 13, and C is equal to minus 4. Then range. Range is what? Range is nothing but the maximum and minimum values what you get. Range will be given by C minus root of A square plus B square and C plus root of A square plus B square. Just substitute the values, children. So you will have it as -4 minus root of 3 root 3 whole square plus 13 square. And you have -4 plus 3 root 3 whole square plus 13 square under root here. 3 root 3 whole square, that is 9 into 3, 27. 27 plus 169, which gives you 196. Root of 196 is 14. So -4 minus 14 minus 4 plus 14. You will have it as -18 and 10. Therefore, range of this function is -8, 10. I'm sure that you will solve this type of problems, and this problem is also an equally important problem for 2 marks. Okay. Now we are into a very interesting concept of compound angles. Now compound angles, when we talk of, it's a combination of 2 angles, isn't it? So we are going to define or derive the formulas for compound angles of different trigonometric ratios. We'll start this by taking a cos function proof, children. If A, B are from the real number set, then cos of A plus B is equal to cos A cos B minus sin A sin B. And cos of A minus B is equal to cos A cos B plus sin A sin B. To prove this statement, we will start taking a small proof with the help of a diagram so that the concept will be clear. Okay. We will try to take a unit circle with the center at the origin, and we will name it as O. Right, children? So we are taking the coordinate axis. We are just taking x-axis. We are taking a circle, of course, with center O. As I was mentioning, it is a unit circle. From O to P, when you take, it is the radius, which is 1 unit distance. Okay, so I am taking a point Q on the circle. Then I'm just joining O to Q, such that this OQ is making some angle with the x-axis. Okay, that angle we will take it as A. Of course, OQ is also radius. OP and OQ both are radii, and at the same time, since it is a unit circle, these two values, that means the length of OP and OQ will be equal to 1. Angle POQ, as we have taken it as A, right? Then since the circle is a unit circle, you will have the coordinates. See, from O to P, the length is 1. It means what? Since it is on the x-axis, the point will take the y coordinate as 0. So P is 1, 0, right? Then OP and OQ, as I was mentioning, it is equal to 1. We will consider, we'll just drop a perpendicular from Q onto the x-axis. Let that meet at one point M, just for our convenience. As I was telling, it is a perpendicular. Then this MOQ triangle will be a right-angled triangle. Clearly, you can see that. Okay, so we will consider this triangle. Then we will just take what is sine A. Sine A formula is what? Opposite by hypotenuse. That means QM by OQ, isn't it? QM by OQ. But what is OQ equal to, children? OQ is equal to 1. So when I substitute OQ is equal to 1 and cross multiply, then I can get QM value as sine A. Likewise, if you calculate cos A, that is adjacent by hypotenuse. So we will get OM, this is adjacent side, by OQ. Here again, OQ is equal to 1. Therefore, when you substitute 1 here and cross multiply, you will get OM is equal to cos A. Therefore, look at this. At this particular point, the value of X is what? Your X value is cos A. And at this particular point, when you go, your y value is sin A. Therefore, coordinates of Q will be given as cos A comma sin A. This type of calculation, children, you will see in your physics topic also when you are taking some proofs. Okay, so coordinates of Q are cos A and sin A. Hope till here I made the concepts very clear, or very clear to you, right? Then quickly we will try to take the extension of this concept. This is what we have seen in the previous slide. Now we'll take another point on the circle R and we will join O to R. Now we will take this OR ray in such a way that the angle made between Q and R, I mean the QOR angle is B. Okay, so we'll just take at the same time OR is nothing but radius again. Therefore, here OP, OQ and OR, all these three are radial and it should be equal to 1 since you're taking a unit circle. Now, angle QOR is equal to B. We will drop a perpendicular from R onto the x-axis, children. Let that meet at N. Then clearly triangle NOR will be a right angle triangle. Right? NOR, angle NOR is a combination now. It is sum of A and B. So I can say angle NOR is nothing but A plus B. Right? Now, for this triangle again, we will try to consider sine and cos. So when I take sine of this angle, it should be sine of A plus B. So sine of A plus B will be equal to opposite by hypotenuse. Here opposite is Rn and hypotenuse is OR. Now, as I was mentioning, OR is the radius, so it should be equal to 1. Go for cross multiplication, children. Then you will get Rn is equal to sine of A plus B. Likewise, we will try to calculate cos of A plus B also. Cos of A plus B is what? On by OR. OR is the hypotenuse. This hypotenuse is nothing but the radius, which is equal to 1. Therefore, when you go for cross multiplication, ON will be equal to cos of A plus B. ON, the distance on the x-axis till N from the origin, is cos of A plus B. And here at this point, the y coordinate is sine of A plus B. Therefore, we can conclude saying that R is nothing but cos of A plus B and sine of A plus B. Okay, so we will take the coordinates. This is same as the previous one what we have taken, but it's a combination of two angles over here. Right? Now, quickly we will go with the extension of the diagram. Till here you have already seen. Right? Now, we'll try to take an angle by taking a point S on the circle, and when we join OS is again the radius. Therefore, radius here again it will be equal to 1. Right? So the angle made here with the x-axis is B, but in the opposite direction. Therefore, you are taking it as minus B, a negative angle. Now, children, so just observe this. A, B are two angles here when you take triangle NOR. So A plus B, magnitude of B and minus B are same. But this positive and negative sign is just because of the change in direction. There is a variation in direction. Okay, so the angle here, the A plus B is numerically equal to this A minus B. Though you have a minus sign over here, this A and B, when you add whatever value you are getting, the same thing you will get by adding these two. Okay, so here we are taking that OP is equal to OQ is equal to OR. It is also equal to OS, which is equal to 1 unit distance. Angle POS is minus B. Now we will drop a perpendicular from S onto the x-axis. It is forming a right angle triangle, right? We will try to calculate what is sine and cos values with this negative angle minus B. So sine of minus B is nothing but SM by OS, opposite by hypotenuse. Right? So OS already we have seen it is equal to 1. Therefore, SM will be equal to sine of minus B. Likewise, cos of minus B will be equal to OM by OS, OM which is the adjacent side for this particular triangle and this angle. Right? So OS is 1 as we were discussing. Therefore, OM is equal to cos of minus B. Cos of minus B is what? Cos B. Right? Therefore, you can conclude saying that the point S will have its coordinates as cos B comma sine of minus B. So we will take that point over here. Now children, angle POR from here to here, this angle, right? It is a sum of angle A and B, right? And when you take angle QOS, that is a sum of A and B only. Of course, this minus B when you are taking, minus we are taking just because of the opposite direction. But numerically, this B and B both are same. Therefore, numerically, we can conclude saying that angle POR and angle QOS both are equal. Now children, I want you to observe a very important point. Now I am just taking a chord with PR. PR is a chord. This chord is making an angle A plus B at the center of the circle. And at the same time, when you take QS, QS is also a chord, which is also making an angle A plus B at the center, equal angles. The two chords what we are taking PR and QS are subtending equal angles at the center. Therefore, we can conclude saying that PR is equal to QS. Now, when PR is equal to QS, we can definitely say PR square will be equal to QS square. Right? This is the diagram what we have seen in the previous slide. Now, here we know all the coordinates, children. We know what is P. P is 1, 0. You know R is cos of A plus B and sine of A plus B. Q is cos A sine A. Then S is cos of minus B comma sine of minus B. Of course, cos of minus B is cos B only. Then we will calculate what is PR square and QS square. PR square, it is a distance formula, what you have been doing in your 10th and also in the locus concept what you have completed recently. So x2 minus x1 whole square plus y2 minus y1 whole square. So when you take that, cos of A plus B minus 1 whole square plus sine of A plus B minus 0 whole square. This is PR square. Now QS square when you take, it is cos A minus cos B. This is of course cos B, isn't it? Right? Cos of minus B is cos B. Then plus you have sine A plus sine B whole square. Then we will expand it by taking A plus B whole square form, children. Now this is A minus B form. Therefore, we will say cos square A plus B minus 2 cos of A plus B, 2AB, right? Plus 1. 1 square is 1. Plus sine of A plus B minus 0 is sine of A plus B only, whole square of that. It will be sine square of A plus B. Then on the other side, cos square A minus 2 cos A cos B plus cos B square, right? And this is A plus B whole square. So you will have cos square A plus 2, sine square A plus 2 sine A sine B plus sine square B. Now we'll try to simplify this further. Now observe these two terms. Cos square of some angle, sine square of some angle. Both the angles are same. Therefore, we can say, we can apply the identity cos square theta plus sine square theta, which is equal to 1. And at the same time, 1 and plus 1, it is 2. 2 minus 2 cos of a plus b. Now look at this. Cos square a plus sine square a. This is again equal to 1. Then you have cos square b plus sine square b. It is equal to 1. 1 plus 1, which is 2, right? 2 minus 2 cos a cos b plus 2 sin a sin b. Now here children, I just want you to make a note. Plus is missing over here. You need to add these two brackets. Okay. Please make a note of this. Here it should be plus. Right. Now, this was the last statement what we have. 2 minus 2 cos of a plus b equal to 1 plus 1 minus 2 cos a cos b plus 2 sin a sin b. Still further we will try to simplify. You have 2 minus 2 cos a cos b, 1 plus 1 which is 2 minus, I am taking 2 common from these two terms, of course minus also. Then you will get cos a cos b minus sin a sin b. We will cancel the terms possible. Okay, then you will have it as cos of a plus b is equal to cos a cos b minus sin a sin b. Right? Now, cos of a minus b, when you calculate, cos of a minus b is nothing but cos of a plus of minus b, which is cos a cos of minus b minus sin a sin of minus b. Sin of minus b is minus sin b, but cos of minus b is cos b only. Therefore, cos of a minus b, we can conclude saying that cos a cos b plus sin a sin b. Now likewise, sin of a plus b, when you calculate, sin of a plus b is nothing but cos of 90 minus of a plus b. You can also rewrite it as cos of 90 minus a minus b. Now how is it looking like? Some cos of some a term minus b, isn't it? So when you apply the formula, cos a cos b plus sin a sin b will be your formula. Instead of a, you have pi by 2 minus a. Pi by 2 minus a with cos will be sin, and if you take sin of that, it will be cos. So you are getting it as sin a cos b plus cos a sin b. Therefore, you can conclude saying that sin of a plus b is equal to sin a cos b plus cos a sin b. Now, once you know this, you can also go with sin of a minus b. Sin of a minus b, we are taking it as sin of a plus of minus b, which is sin a cos of minus b plus cos a sin of minus b. As we were discussing, cos of minus b will be cos b, sin of minus b will be sin minus sin b. Therefore, you have sin a cos b minus cos a sin b. Hence, we can conclude saying that sin of a minus b will be equal to sin of a minus sin a cos b minus cos a sin b. Now, children, this proof what we have discussed will not be asked in your exam. But is it not an important thing to know how you got this formula? That is the reason why I wanted to get into the depth of the concept. At some point of time, if you cannot remember the formula, you can very well derive by taking this logic. Okay, so we will just try to have a list of all these formulas in one slide. The first four, what you are seeing, we have derived. But tan of a plus b, you can calculate by taking sin of a plus b by cos of a plus b. And you can also calculate tan of a minus b by taking sin of a minus b by cos of a minus b. You can try it out. Likewise, cot of a plus b and cot of a minus b also. And it is very important for you to remember these formulae. Now, based on these compound angles, you need to find the values of certain, again, you can say standard values, right? Sin 75, if you are asked to calculate, then how to go with? See, all the values you cannot remember. So we will try to convert this angle which is given to us into the form where you can apply the compound angles and also your standard trigonometric angles, trigonometric values. Okay, so sine 75, we will write it as sine 45 plus 30. Then you can very well apply this formula sine of a plus b equal to sine a cos b plus cos a sine b. Then when you do so, you will get sine 45 cos 30 plus cos 45 sine 30. You know sine 45, cos 45, cos 30 and sine 30. Just substitute those values. Then when you do so, you will get it as, see, 2 root 2 is your LCM, right? So you'll have root 3 plus 1. So root 3 plus 1 by 2 root 2 is sine 75. Got it, children? Now suppose if you want cos 15. Cos 15 is nothing but cos of 90 minus 75, which is sine 75. That means you are applying 90 minus theta formula also here to get another value, that is cos 15. So cos 15 also can be calculated, and cos 15 is nothing but sine 75. Now, we'll look into another problem with 15 degrees, tan 15 degrees, children. Tan 15 is tan of 45 minus 30. See, we are very choosy when you're taking the when we are taking the angles, isn't it? We have taken it as 45 and 30. Why? Because we know the values of 45 and 30 degrees for all the trigonometric ratios, isn't it? So 45 and 30, when you take it, is 15. So the formula what we have seen is tan of a minus b is tan a minus tan b by 1 plus tan a tan b. So just we are substituting a and b values as 45 and 30. Then tan 45 is 1 and tan 30 is 1 by root 3. So we'll just substitute those values. Then in the numerator, when you calculate, the LCM is root 3. So root 3 minus 1 by root 3. And in the denominator, again, the LCM is root 3. So you're getting it as root 3 plus 1. Root 3 and root 3, they get cancelled. Then you're left with root 3 minus 1 by root 3 plus 1. Now, you cannot leave any third in the denominator. This you have learned in your 9th class. So we will try to rationalize the denominator by multiplying with its conjugate or its rationalizing factor. Now, when you multiply so, you will get it as root 3 minus 1 whole square by, in the denominator, it is a plus b into a minus b form, which is root 3 whole square minus 1 square. So root 3 whole square is 3 minus 1, which is 2. And in the numerator, when you expand, it will be 3 minus 2 root 3 plus 1. Of course, a minus b whole square. So you will have it as 4 minus 2 root 3 by 2, which is, when you take 2 common, you will have 2 minus root 3. So 2 and 2 vanishes, children. It gets cancelled. So you are left with 2 minus root 3. Therefore, we can conclude saying that tan 15 is 2 minus root 3. Now, at the same time, cot 75. Cot 75 is nothing but cot of 90 minus 15. Cot of 90 minus 15 is what? Tan 15. That means cot 75 and tan 15. Both are same. See, you are applying different formulas what you have learned. This is the application part of the concepts what we have discussed yesterday and also today. Now, similarly, there is a small work for you, and hope that I don't say hope, but I'm very sure that you will feel that it is an interesting concept. And right now, immediately after my class, you will try out calculating cos 75, tan 75 and cot 75 values. You can take the screenshot of these values and you can cross check whether you have whether you are getting the same values or not. Just try it out, children. And here are some practice questions. Simple questions, and at the same time you will be able to solve 2 mark questions if you are solving this. We have discussed what is period, how to calculate the function, given function when period is given. We have seen how to calculate range and also maximum and minimum values. Thank you. You can take the screenshot of the practice questions also.
Thank you, Usha ma'am.
Thank you, madam.
Thank you for your wonderful explanation. I hope each and every student might have understood your class. Thank you. Thank you, ma'am. And dear children, please watch our YouTube channel and please write down the notes. Please subscribe the channel, children. Please like our all lessons. And thank you, Usha ma'am, for your wonderful explanation.
Thank you, madam.
Thank you.